Hey everyone, this is Ashish from Developer Hut and welcome to the next topic of Go for Beginners series, which is recursive functions. So what is recursive function? So recursive function is that function who calls again and again till it reaches to certain stop condition. Now recursive function or recursion is a very powerful concept and it is available in most of the programming languages. So let's try to create some recursive function using this definition. So let's say I will create one function. I will say function, will say test, and it accept parameter, let's say x, which is of type int. Okay. Now what we said is we will call this function again. Only after that this will be a recursive function. So let's print this first. So I will say fmt dot println and I will simply say x, right? And let's call this function. So one more thing, we need to add the return statement here. So I will say it will return an int. Okay, either name return or a name return, both will be okay. So I will say return, again it will call the test. Okay, I will only modify the value. I will say x plus 1. Okay, so now if you try to call this function, right, what will happen? This program will run and it will go out of memory because we didn't add any stop condition. So recursive function always and always or must have some stop condition. So this is the big risk while recursive function. If you didn't write the recursive function properly, then in that case your program will end abruptly. Okay, so always remember that you have to add some stop condition. Okay, so let's add some stop condition. So I will say if x equal to 5, then I will say return 0. Okay, so this is my stop condition for this. Now let's try to run this program. So I will say go run and recursion.go. So here you can see we printed all the values, right? So the first value of x is 1. It is not equal to 5. Then it will print the x and then it will call the function again. Then again it will go with the new value, which is 2, which is not equal to 5, and this will continue and this will go on. Okay, so this is how we can write the recursive function. So factorial is very important concept in a mathematics, and this is very heavily used to understand the recursive function. So we will see what exactly the factorial is first, and then we will create a recursive function around it, right? So what is factorial? So factorial is a product of all the positive integers which is less than or equal to that particular given number. So factorial formula is like this, where we have the given number which is 4 and then we use the product of all is less than numbers. So for example 4 into 3 into 2 into 1. Okay, and the final output is 24. Similarly we have a 6. Similarly the factorial of 6 is 6 into 5 into 4 into 3 into 1, which is 720. Okay, so this is basically the factorial. So now let's try to create the factorial function, which is recursive function in our case. So the formula for factorial is n into n minus 1 into n minus 2. So on the basis of this formula, we will try to create a recursive function. So let's create one function. So I will say function, which is, let's say, factorial. Okay, and this will take the value, which is, let's say, x. Okay, and I will say int. Okay, and this will return one value, which is, let's say, I will say y, which is int. Okay, and so let's create the n first. So I will say n is equal to factorial of what? Of x minus 1. Okay, so previous value, which is n minus 1. So we are calculating this first and we are storing it in n variable. Now once this is done, then we will use our y to store the value. So I will say x into n, right? So we achieve this part, right? So n into n minus 1. okay, which is in our case x into n, and we are stored into y, okay. And then let's print it. So I will say fmt dot printf, and here I will say %v into %v equal to %v, okay. I will also add slash n, and here I will say x comma n comma y, okay. So here we are calling the function again and again, which makes our function is a recursive function. Now one more important thing here is we need to add the some stop condition, okay. So I will simply add the condition. So I will say if my x is, let's say my x is greater than 0, only after that you can execute this block, okay. Otherwise we don't need to execute this. So what happened in else case? So I will say else we will assign the y equal to 1, and then lastly we will return, okay. This is the name return, so that's why we don't need to say return y, okay. So let's check this once again. So we call the factorial of n minus 1, right, which is this, and we make the product and we print it, okay. This will happen till we reaches to the 1, and lastly when x is greater than 0 or x is equal to 0, then in that case we return 1, okay. Now let's try to, I will just comment this and I will say factorial of, let's try to pass the same value, which is 4. Let's try to run this. So I will here say go run and recursion, okay. So here you can see we got the actual last output, which is 24. So this is how we can calculate the factorial value, right. Now let's try to understand this, how this function actually worked. So we call the function which is factorial and we pass the value 4. So what will happen, as per our program that we wrote, we call the factorial of 4 minus 1, which is 3, factorial of 3. So we calculate the factorial of 3, and then we assign the product of these two to the y value, right. But in factorial of 3, what will happen again? The same thing. It will say the factorial of 2, right, which is 3 minus 1. And then when we call factorial of 2, it will again call factorial of 1, right, and the same on till we go to the 0. Once we say when value is equal to 0, at that time it will return simply 1. So 1 into 1 is equal to 1, right, and then we got the first output, right, and then we say the last input, which is 2, and the output of factorial 1, which is 1, which is 2, and then the same will go on. So this is how we calculate the value of factorial 4. So if you see here carefully, this is nothing but the call stack, right, or method call stack. So first we call the factorial of 4. So this method will wait for the output of the same method again, right. The first method which is called in the call stack will wait for another method return value, right. So this is how the call stack will happen. So at the end, when we call the factorial of 0, this method will end first, and then the second method, the calling method or the parent method, will end secondly. So this is how the method stack will work. So this is how the recursive function will work in case of the factorial. So here if you see carefully, so the first execution is 1 into 1, right, then second execution, so this output will go to the previous call, which is 2 into 1, right, and then this output will go to the previous call. So this is how we can create the recursive function of a factorial. So I hope you understand the concept of recursion. Recursion is very trickier concept, and it is very difficult to build as well, because if there is a small mistake in your program execution may abrupt during the runtime. So you have to use the recursion in very careful way. So make sure that you avoid the recursion, but in some cases it is very powerful and memory efficient as well. So I also uploaded few assignments on the GitHub repository. So once you finish with this video, please try to complete those assignments so that you can make your recursion concept better. Okay. If you have any questions on this, you can add it in the comment section below. Thanks for watching, and I will see you on the next one.